8. Welcome to another video where I will be discussing questions related to paper 2, grade 8 mathematics, and the three different sections that you get is data handling, geometry, and measurement. Okay, so measurement is area and perimeter, surface area and volume. Then under geometry, you get geometry of straight lines, you get geometry of the triangle, you get similarity and congruency, as well as Pythagoras. Okay, so in this video, I'm going to be covering all those types of questions. And not just easy type questions, also harder type questions, so that you can get used to looking at level 3, level 4 type questions where it's a little bit harder, it's a bit more real life, and yeah, just work with me, see what I'm saying, remind yourselves of the rules, and you will do well for paper 2. All right, so let's get going. It says question 1. So what I've done is I've copied and pasted all my past papers into different sections. So all my past papers that I thought was good questions on geometry, I've pasted into this PDF file, as well as the measurement, which will come soon hereafter, another video on measurement, and then another measurement where somebody asked me to make a video on data handling. So remember, those are your three types of topics that you get, or the three topics that you do deal with in paper 2 mathematics. So this one is the first one, and this is all about geometry. All right, okay, so easy type question where they ask you, provide the correct reason for the following statement. So they say to you, x plus 120 is 180, thus x is 60. And the correct reason there will be, lots of you, if I had to just write the proper reason, is supplementary adjacent angles. What we also teach the students is angles on a straight line. And we know that angles on a straight line add up to 180. Okay, in the next one, they say to you, x is 100. And the reason for that is because we know that vertically opposite angles are equal. So just please remember the vertically opposite angles. Number C, they say to you 2x plus x is equal to 180, and then thereafter they could work out x with your algebra equations. So I'm going to know that this is the angles of a triangle, and I always want to write interior angles of a triangle. Okay, and we know that that adds up to 180. Over here, co-interior angles. Can you see your bowl with your fun? That's why they gave me the parallel lines. So it's co-interior angles, and very important, we need to state which two sides are parallel to which other side. Okay, so there's all your reasons. That was an easy, hopefully 5 marks. Okay, let's move on. Question 2. They say to you KLMN is a rhombus. So now, very important, the write-up, I always say, don't forget and just rush through to the questions. Read your write-up and just understand what they've given you. KLMN is a rhombus. So very important. We need to know the properties of a rhombus. We need to know the properties of our parallelograms. I always say to my students, it's so easy just to see the properties. We can sort of assume, we can look and say, but that looks very, it should look like 90, so it most likely is 90. So all your properties, very important to go through. And then they say to you, KLM, which they haven't written on your picture. So that's why, do you see how important it is to read your write-up to get information that might have not been depicted in your picture. Okay, the length of the diagonal KM, so KM altogether is 10 centimeters. So KM is 10 centimeters. Okay, so now if we just had to remind ourselves of the properties of a rhombus, let me work it through with you. All sides of a rhombus are equal. So remember, that side's going to be equal to that side, is going to be equal to that side. as well as the opposite sides of a rhombus are parallel. Okay, so you don't have to, if you want to go put it in, you can. I just don't want to overcrowd my picture now. And then they say also another property, opposite angles of a rhombus are equal. So if this L is 58, we know that that N1 and 2 will also be 58. And then in a rhombus, diagonals bisect each other at a right angle. So that E1 will be equal to 90 degrees. And then the sum, let me just quickly see which other ones I failed to mention. And this side over here will obviously be equal to that M over there. Okay, so let's just see what they've asked. They said to me that KL will be parallel to NM, because we know that the opposite sides of a rhombus are parallel. So KL, is parallel to NM. They didn't even ask me to state the reason. They just want you to see that you know the reasons. E1 is 90 degrees. N2 over there, because these two are actually congruent triangles, it means also that the angle there gets split into two. So N2 will be equal to the 58 divided by 2. Okay, so 58 divided by 2 will give you 25 plus 4, which gives you 29 degrees, because we know that the diagonals of a rhombus bisect each vertex angle. Okay, so like I said, this triangle over here is congruent to this triangle over here, and as well as this side over there and there. So the diagonals of a rhombus bisect each vertex angle. So we can know. And if you perhaps forgot that and you say, well, let me work with what has been given, the only thing to do is that to take that 58 and divide it by 2. Because of this side, now my picture is very overcrowded. Because if this side over here is 58, it means that this side over here is 58, and then it gets divided into 2. All right, number 4. So EM is equal to this part, which we know KM was given as 10. So we can then assume that EM will be 5 centimeters, because in a rhombus, diagonals bisect each other. So what that means is that this line will be exactly equal to that line, because those are the diagonals that are bisecting, and they bisect at a 90 degree. And this one over there will be that sides as well. So they will be equal there as well. And then they say to you, K and L are equal to what? So K plus L will be equal to, could you have guessed it, 180 degrees, because they are parallel. They form co-interior angles like that. So we know that K and L definitely together will give you 180 degrees. Okay, I hope that makes sense. Again, if you forget some of your properties, just look at what has been given and say, how can I get the answer how can I derive an answer from what has been given? And then maybe just by common sense, you can find the answer. Okay. Right, and when they say classify triangle EML in terms of its angles, then we can say, but we know that EML, that is a 90 degrees, so it's a right angled triangle, or you could have said a 90-degree triangle. Okay, and then they say classify KLN. So let me just KLN over there. And because we know that all sides of a rhombus are equal, we know that these two sides will be equal, which makes it an isosceles triangle. Okay, and don't worry if you can't spell isosceles, just try. I'm sure your teacher will figure it out. Okay, it's an isosceles triangle. All right, let's move on. Now, again, they ask you, please remember to read your write-up. Read, guys. In the diagram below, KL is parallel to MN. So if you're scared you're going to miss that parallel lines, highlight them nicely with a nice highlighter color. Use the diagram and give reasons for the statements. Okay, so they say to you A2 is equal to A4. Why is that? Because of, let me just get a nice color here. It's because of, you've guessed it, vertically opposite angles. A3 over here is equal to G3. And then if you don't know why, just draw lines that are around those two purple dots. And you can see it's a corresponding, corresponding angles. I always remind my kids, I say, I'm walking down a corridor and I see a big F. Okay, so always that you remember the F stands for corresponding angles. And then very important, I have to say KL is parallel to MN. Okay, otherwise you do not get that mark. And that, how sad would that be? Okay, A4, so again A4 is equal to G2. Okay, and if you highlight those lines that are surrounding those dots over there, can you see it's a N or a Z, which stands for, say, you've guessed it, alternate angles. But again, we have to state which ones are parallel. And luckily, it's just those two that are parallel, so you can't get that wrong. Okay, it's a Z, an N, or a Z, which is alternate angles. Okay, anything that gives me 360, we know, is angles around a point. So G1 plus G2 plus G3 plus G4 will give you 360. Why? Because of angles around a point. And then last one, A3 plus A4. A3 plus A4 gives you 180. Why is that? Because it's angles on a straight line. If you want to say adjacent supplementary angles, that's also fine. So angles on a straight line. Perfect. That was not hard. Okay, now we're getting into the little bit harder questions, but you can do this. I know you can. In the diagram below, again, AB is parallel to CD. And then they say to you, calculate the values of X and Y with reasons. So let's start with X. Okay, so 2X plus 3X plus X. Can you see all together? They are laying on a straight line. So together I know they will give me 180 degrees because of angles on a straight line. And now we have to use a bit of algebra. 3, 4, 5, 6x is equal to 180. And when I divide with 6 on both sides, I get x is 30 degrees. Okay, so x is 30 degrees. Now we have to find y. Can you see? They haven't given me that it's an isosceles triangle, so I can't go and say that is y over there. What they have given me is that these lines are parallel. And whenever they give you parallel lines, people, you will know that you have to use the F, the U, or the N somewhere, somehow. Okay, so if you look over here, can you see that Z lying over there? Okay, there's no co-interior that involves my Y, and there's no U that involves my Y. Oh, we could have actually done U as well. So there's lots of ways with geometry. Your teacher will always mark. She marks with a memo, but she always keeps an eye out for something that she perhaps missed. Okay, so there is a co-interior as well. Okay, so I've scratched out most of my values there, but we know that y together with 3y together with y together with that 3x plus that x will give you 180. So that is one way of doing it. The other way is, I'm just going to go back to my z over there, which is alternate angles, and can you see that y will be equal to 2x? because of alternate angles, and very important, you have to say AB is parallel to CD. So then we know that x is 30. So when we replace it in there, 2 times 30 is that y gives you 60 degrees. Okay, hopefully still not too hard, building up to it. All right, a little bit harder now. Given that ACF, so you must follow, sorry, I went from B. So A, just trying to get that, CF, so that angle over there, C1 and C2, together gives you 130 degrees. Okay, they say to you, and AB is parallel to CD, is parallel to EF. Okay, so all these three lines, let me do it in a different color. All these three are parallel to each other. Okay, calculate the size of F1 over here with reasons. Okay, now can you see that we can find C1? Let me just get a different color so that you can follow me nicely. We can get C1 because of co-interior angles. So that's C1 plus A gives you 110. Oh, sorry, does not give you 110. It gives you 180 degrees because of co-interior angles. And now, which one are we using with that bowl? It's those two. So it's AB that is parallel to CD. All right. Okay, now can you see that we know A? So we're going to say C plus 110 gives you 180. And if you want to subtract 110 on both sides, you'll get that C is equal to 70 degrees. Okay, so this one is 70 over there. But remember, they told me that C1 and C2 is 130 degrees. So you can write given. And C1, let me just write C1 over here, sorry, so that we know which one I was talking about. So C1, we know, is 70 degrees. So I know some teachers say you must write that again and say proven, but you can just go ahead as well and put it in there because the teacher will be able to follow your logic. Okay, so C2 is equal to 60 degrees. Okay, so now I've got C2 is 60 degrees, and then at the end, can you see over here is a Z, which makes alternate angles, which makes F1 equal to C2. And again, you can immediately say is equal to 60. And why is that? I just want to get it another color so that you can see it. Maybe the yellow is a bit unclear. And that's because of alternate angles. And which two lines did I use for parallel lines? Can you say it's, oh sorry, can you see it's CD that is parallel to EF? Okay, luckily with geometry you must use a lot of colors, and luckily with this video you can see the colors and hopefully it helps a lot. But I always say to the students, get as many highlights as you can, and if it's unclear or you've done something, redraw the picture next to the picture given and then start afresh, and maybe you see something else. Especially when you redraw that picture, sometimes something pops out and you understand or you can see it a bit better. Okay, all right. Now they say to you, determine the size of E over here with reasons. Let angle D be X, like they've given it to you already. Okay, now can you see, if we just look at the picture, because AB over there is equal to AC, as well as BC is equal to CF, we can take it that AD is equal to AE, which makes it an isosceles triangle, which will make it that this angle over here is equal to that angle over there. Okay, so I'm just going to unclutter again. All right, and now can you see that AB is also an isosceles triangle, which will make 80 plus B1 plus C1, which is the same as each other, equal to 180 because of interior angles of a triangle. Okay, so let's just get C1 for now, or B1 basically. Why? Because if I get that, can you see your alternate angles, the F lying over here? Okay, and why is it this side? Because this side is the one they are wanting me to find. Okay, so again, let's just declutter. All right, so I'm going to start B1 plus C1 plus A is equal to 180 degrees. And that is because of interior angles of a triangle. Okay, but C1 is equal to B1. And if you wanted to, you could already work it out. Okay, so 180 minus 80 is 100, and 100 divided by 2, which gives you each 50 degrees. Okay, because I already said interior angles of a triangle. The only reason now missing is angles opposite equal sides. I know some teachers say you may write isosceles triangle. Yeah, it's still debatable whether that is correct, but yeah, the most correct is angles opposite equal sides. Okay, now, can you see this F lying over here? All right, so we didn't actually need, we could have gone straight into X. I'll show you now, but with the corresponding angles, can you see that X will also be equal to 50 degrees? So X is also equal to 50 degrees because of corresponding angles. BC is parallel to DE. And that was it. Okay, for 4 marks. So 1, 2 over here, 3, 4 over there. Okay, so the other way you could have done it is you could have just worked with a big triangle where you started with AB is equal to AC and BD is equal to CE, and then you can say that was given, thus AD is equal to AE. Then you could have worked out B1 is equal to 50 degrees because of angles opposite equal sides. And then you could have said that X is equal to, sorry, I wanted to go the different route. Sorry. Let me take that out. So once we got that those are the same length, we can immediately work with an isosceles triangle. So where you can say A plus X plus E is equal to 180 because of interior angles of a triangle. But then you can say X is equal to E and then is equal to 50 because of angles opposite equal sides or isosceles triangle. Okay. Hope it makes sense. Hope you could see next time. Yes, maybe I'll be able to do that. Okay, and then similarity and congruency. Oh, people, these are the easiest marks if you just know how to do it. And there is a video where I explain to you just similarity and congruency, and it's nicely laid out with the one side where I do similarity and the other side where I do congruency, and it's sort of simultaneously done so that you can see exactly what the difference is and how to tackle those questions. So if you still struggle with this, please go look at that video. It could have been under grade 8 or grade 9 because it's basically the same. Just please go and have a look there and I can help you with that. All right. So it says to you, triangle ABC is similar to triangle EDC. So yeah, you didn't have to prove similarity, but if you had to prove similarity, remember there's 2 ways, all sides in proportion, but very important, you need to have all sides, or angle, angle, angle. But now they've told you already that these two are similar. And they say to you, find the length of BC. Okay, so now they didn't tell you which triangle is equal or is similar to which triangle. Okay, now they did. Sorry. Triangle ABC is similar to triangle EDC. Okay, so we've got ABC is similar to EDC. And let me just add a triangle to make it perfect. Okay, so you can do your smiley write-up that we know that AB will be in ratio to ED, BC will be in ratio to DC, and AC will be in ratio to ED. So I'm going to write that up. AB over ED is equal to BC over DC, which is equal to AC over EC. And your reason here will be all sides in proportion, given that triangle ABC is similar to triangle EDC. Okay, so now we're just going to replace AB with 15 over ED, which is 105. So here's my complete fraction, is equal to BC, which we are looking for, over DC, which is 49. Okay, so I don't even have to, I could have continued and said is equal to AC, which is 21 over EC, but we didn't really need that fraction. We just need one complete fraction. So I just want to double check the one that I'm using. AB is equal over ED, which is 105. Okay, so sorry, I'm going to go a bit over the space. So now you're going to write up your fractions, one complete one, with one that you want, that BC, and then we're going to do the butterfly, the cross multiplication. So BC, so times by 105, gives you 105 BC, is equal to 15 times 49, which gives you 735. Now to get BC alone, I'm going to divide with 105 on both sides. Divide with 105, which gives you BC is equal to 7 centimeters. Okay, I think that's the easiest way, especially if you don't have a perfect fraction to relate to or to use. Just do the cross multiplication and then let algebra take you from there. Okay. Question 3. Calculate the size of x. Round your answer off to the nearest one decimal place. So whenever they say that, please pay attention to that. Although I know most papers you have to round off to the nearest one decimal now. But let's just, remember those write-up things and the special orders that they give us. Okay, so can you see Pythagoras? People, when you see a 90 degrees, always think Pythagoras. Okay, now with Pythagoras, it's the two sides touching that 90 degrees added together squared. So let's stick to that. Stick to that formula when you write it up. So AD squared plus DC squared is equal to AC squared. And you have to always thank, oh dear, Pythagoras for that. Okay, then AD squared plus DC squared is 8 squared is equal to 10 squared. So AD is going to be equal to, so you can say 10 squared minus 8 squared gives you 36, and the square root of 36 is 6. Okay, so please remember your algebra. I hope you could work that out. So this one over here is 6. Oh, no, wait, sorry. Oh, yes. So this is 8. Now, if you look at the whole measurement here given, the whole from this point over here up to that point over here is 13. So 13, what? And 8 gives you 13. And hopefully very clearly, you could see that your answer would be 13 minus 8, which gives you 5 centimeters. Okay, so now I've got the two sides touching the 90 degrees. Squared added together will give you that x squared. So I'm just going to do the write up. So 5 squared plus 6 squared is equal to x squared. And again, you have to write Pythagoras. So 25 plus 36 is equal to x squared. And 25 plus 36 gives you 61. I'm just going to swap it around so that I've got x squared first. So all I did is I just swapped the x squared on the left and the numbers on the right. And then to get x alone, I'm going to plus minus square root 61. If you're not with the plus minus yet, don't stress. You'll soon start hearing that from your teachers, that if you square root a number, you always have to add a plus or a minus. Okay, but for now, because we're working with distance, it will always be a positive, which is 7.8 centimeters. Okay, if you want to have a look at the picture again before we move on. Okay, question 4. Congruency. In the following diagram, it is given that AC is equal to DC. Okay, so those two are equal. So I'm going to use highlighters on your paper. BC is equal to CE. And the last one, and both triangle ABC and triangle DEC is a right angled triangle. Everything has been given, nothing you had to figure out by yourself. Okay, let's have a look. Prove that triangle ABC is congruent to triangle DEC. Now, people, we need congruency. Remember, there's a in the SAS, in the SAA, right angle hypotenuse side, ASA. Okay, and can you see, whenever you've got a 90 degree, it's most probably going to be right angle hypotenuse side. Okay, so let's start. We just need to say that 3 things are equal to 3 things of the other triangle, thus they're going to be congruent. So we want to name 1, 2, 3 things that are going to be the same. Thus, triangle ABC is congruent to triangle DEC, and most likely, I just want to make double sure, is right angle hypotenuse side. Okay, so we've got the right angle, we've got the hypotenuse, which is always across from the 90 degree, and then any other side. So they could have given me DE is also equal to AB. Another way we could have asked this question is that I could have given it to you that ADBE is a rectangle. And then what do we know with the properties of a rectangle? The opposite sides are equal. So then you could have said AB is equal to DE, and that would have been another side that you could have proven that are the same. Okay, so over here, I'm going to say angle B is equal to angle E. You can add is equal to 90 degrees. And all 3 things, the reasons are going to be given. So very easy. Can you see? Please don't be scared. Lots of you hate congruency, hate similarity, but it's the easiest marks ever. So AC is equal to DC. Just want to get the order right. And that's also been given. You could have added that it's 5 centimeters. And then the last thing is BC. BC is equal to EC. And that's also been given. Another thing, I'm thinking of all these questions. It could have been 5 centimeters, and I could have given you 4 centimeters over here. And then with Pythagoras, you could have worked out that the third one is 3. So there's lots of ways I could have adapted this question to make it a bit harder so that not everything is given. Let me just erase that extra part. Okay, so they are congruent, right angle hypotenuse side. Hence prove that AB is equal to DE. But AB is equal to DE. Look at that. AB is equal to DE. We're just going to say they are. Why? Because proven that triangle ABC is congruent to triangle DEC. Okay, you've proven it. They are congruent. So they play matchy-matchy. They play match-up with the write-up. So everything's good. Okay. Question 5. The following diagram is given with all the measurements as indicated. If AB is parallel to DE over there, prove that triangle ABC is similar to triangle EDC. Now remember, with similarity, it's either all sides in proportion, and at the moment I don't have all sides. Look there, one is missing. So can I use all sides in proportion? No. We have to use angle, angle, angle. So we need to find 3 angles that are equal from the one triangle to the other triangle. Now, the easiest one to look out for is, can you see that C1 is going to be equal to C2 because of vertically opposite angles? Okay, so the first one, C1 is equal to C2 because of vertically opposite angles. The next one, sorry, let me just get a nice bright color. Can you see that this A, because those two are parallel, A will be equal to E because of what? Hope you guessed it, alternate angles. Okay, so angle A is equal to angle E because of alternate angles, given that AB is parallel to DE. And also now the other way around. If you look at it from this side, those are also alternate angles. So this angle over here is equal to that angle there because also of alternate angles. So angle B is equal to angle D, also because of alternate angles, AB parallel to DE. So thus I'm going to say, thus triangle ABC is similar to triangle EDC because of angle, angle, angle. Okay, now they say to determine the length of X and Y. Okay, so first of all, smiley write-up. So I'm going to use my sort of my secret code to write up my ratio parts. AB will be equal, or over ED, sorry, will be equal to BC over DC. And I'm always following this pattern. First, second, second, last, first, last. AC over EC. Okay, so now your reason here, proven triangle ABC is similar to triangle EDC, all sides in proportion. Okay, now let's look. What is AB? AB is 7. And ED is X, is equal to BC, which is Y, over DC, which is 6, is equal to AC, which is 5, over EC, which is 10. Okay, so now this is very easy to see. Can you see the bottom? If you take it and you half it, you get the top. Okay, so if I want to work the other way, if I take the top, I have to times it by 2 to get the bottom. So what do you think X would be? I hope you've guessed it, 14 centimeters. And by looking at that rule that I've created or can see or derive from my fraction, from 5 to 10, what to 6? 3 centimeters. And if it wasn't easy to see, you could have also done your cross multiplication. This fraction with that one, and then next that one with that one. Okay. Easy peasy. Okay, another Pythagoras. When you see right angle triangle, think Pythagoras. Below is a diagram that is not drawn to scale. Calculate the length of X. So again, first we'll have to find AC, and once we've got AC, we'll have 1, 2 out of the lengths of this triangle here on top to find that x over there. All right, so first step is we want to find AC. So now can you see AC is going to be your hypotenuse, which is your longest length. And remember how I told you with Pythagoras, it's the two sides touching the 90 degrees. Added together squared will give you that AC, hypotenuse squared. So you can immediately start replacing your values. You don't have to write AB squared is equal to, AB squared plus BC squared is equal to AC squared. You can just say 5 squared plus 12 squared is equal to AC squared. And that is because of Pythagoras. I even told my kids, if you can see 3, 4, and you know the hypotenuse is then 5, you can just write x is 5 because of Pythagoras. If you know your Pythagorean triplets, you can just write it down. Another one is 6, 8, 10. So in grade 8 and 9, they love to give you those triplets to work with because it gives you nice whole answers. Okay, so 12 squared plus 5 squared gives you 169. If you square root, you'll find plus minus 13, but because you're grade 8, don't stress about that yet. It's 13 centimeters, and as well, because it's distance, it will always be a positive. Okay, then we go replace the 13 in there. Now I know, again, it's the two sides in the upper triangle added together squared, or squared added together, will give you the hypotenuse squared. Okay, so it's basically AC squared, which we worked out now as 13 squared, plus CD squared, which we see there is 84 squared, is equal to our x squared. Again, thank you, Mr. Pythagoras. Please write it down always. 13 squared plus 84 squared gives you 7225. And if you square root 7225, you'll get plus minus 85. But because it's a distance, we'll always just write it down as the positive 85. Goody, goody. I hope you're okay with that. And then question 7. Right, we are almost done. We are getting there. Okay, in the given figure, AB is parallel to CD, which is also parallel to EF. Okay, so again, immediately, can you see that Z lying over there? So we know that A1 plus 25 will give you 60 degrees. So we can basically find that A1 already. And then AEF is 60 and CAE is 25, like it's labeled there. Calculate the size of C1. Okay, then after finding A1, can you see if we add these together, it creates a bowl, which is my co-interior angles. Okay, so I'm just going to write it down. A1 plus 25 will give you 60 because of, alternate angles. And because of AB, that is parallel to FE. Okay, so there's my Z lying over there. But now, if you look here, those two together must give you 180. So let's just quickly work out A1, 60 minus 25 is 30, 40, 50, 60. Okay, it's 35 degrees. Let me just double check. 35, okay. So now, let me just clean up here a bit so you can see what's going on. Okay, so can you see I worked with that Z over there together this. So if you just ignore that black line, you would have easily seen it. Okay, so just ignore that and, don't always, get confused with other lines that are drawn there. Okay, but now if we change our mind's eye, to this part over here, those are also now parallel, which makes these two added together equal to 180. So please remember that. So A1 plus C1 is equal to 180 because of co-interior angles AB parallel to CD. A1 was 35, so 180 minus 35 gives you 145. So C1 is equal to 145 degrees. Okay, can you see it nicely? Let me just rewrite it beautifully. 145 degrees. Perfect. Then they say to you, find the values of x and y. Okay, so first of all, can you see that x and 78 lies on a straight line? So x plus 78 is equal to 180. Adjacent supplementary angles or angles on a straight line. Thus, x is equal to 102 degrees. How did I get that? I said 180 minus 78, which gives you 102. Okay, once you get it, go replace it in there. Okay, so now you could have either gone with angles on a straight line again, knowing that all of those will give you 180, or you could have gone with vertically opposite angles, knowing that that is equal to that. Okay, let's do that one. 102 minus 2y is equal to 78 because of vertically opposite angles. And now it's just left, or your algebra, I'm going to bring the 78 over here and subtract it. And I'm going to take the negative 2y over and make it a positive 2y. So 102 minus 78 gives you 24 degrees. So thus, y is equal to divide by 2 on each side. Y is 12 degrees. Okay, hope it makes sense. Number C, find the value of x with reasons. Okay, a little bit of a harder one. Let's see where we would start. So we know that these two are co-interior angles. Okay, so we know those two together will give you 180. We can also say that this will be equal to G1 because of the F. And if you can't see the F, let me just quickly highlight it for you. Like so. Okay, so now how would I find G1? Let's use this to find G1, and then we can say that G1 is going to be equal to 2x plus 20 because of corresponding angles. Okay, so now can you see G1 and that x plus 10 added together will give you 180 because of angles on a straight line? Okay, let me just clear up a bit. Okay, so what would G1 be equal to? So if you say G1 plus x plus 10 will give you 180 degrees. Okay, so now we want to know G1 over here. So G1, if we had to get G1 alone, is equal to 180 minus 10 minus x. So G1 is equal to 170 degrees minus x. Okay, and the reason here, angles on a straight line or adjacent supplementary angles. Okay, now can you see we've got G1? G1 is 170 minus x, which is this one over here. And we know because of corresponding angles that G1 will be equal to 2x plus 20. Okay, so G1, which is this, will be equal to 2x plus 20. And can you see with that, I'm creating an equation that just involves x's, which means I can solve that x. Okay, and this is because of corresponding angles, GB, or rather BG, or GB is parallel to HD, or you could have said CD. Okay, as long as I can see which line you are talking about. Okay, now let's say 170 minus 20 is equal to 2x plus x. So I'm just solving x. 150 degrees is equal to 3x. Thus, x is equal to 50 degrees. Okay, so there could have been other ways that you worked it out. You could have worked out H1 and G1 in terms of x and then say interior angles of a triangle. Sorry, not interior angles. The interiors of co-interior angles gives you 180. I'm trying to think now quickly of other ways you could have done that. Yeah, so it's a bit of a harder question, this. Level 3, level 4. So, rather level 3 question where you have to especially work in terms of x. Okay, now the last ones are really a little bit heavier. So if you're not used to the heavies, like level 3, level 4 type question, especially IB, then don't stress too much if you can't do this. Okay, but let's look. Question 8. If AD is perpendicular to BC, so they meet at 90 degrees. So remember Pythagoras, if I need to use it somewhere. It says determine the perimeter of the triangle in terms of x. Okay, now the perimeter of the triangle is 9x squared plus 6x squared plus 3x squared. Okay, so it's just all the outer lengths added together. That's not too bad. What makes it a level 4, it's because of it's in terms of x. We're not going to find an answer. And then can I add those together? Yes, I can, because they are like terms, which gives it 18x squared. 9 plus 3 is 12, plus 6 is 18. Okay, now they say to you, determine the area of the triangle in terms of x. Now the area of a triangle is base times height divided by 2. Do I have the base? Yes. Do I have the height? Yes. Okay, so I didn't have to use Pythagoras or nothing here. Everything has been given. Okay, I just need to follow my formula. So it's going to be 6x squared times 5x divided by 2. Okay, and hopefully your algebra sets in. Okay, 6 times 5 is 30. X squared times x is x to the power 3. And if I divide it by 2, I get 15x to the power of 3. Okay, you don't find an answer, it's in terms of x. All right, so I hope you were able to follow that a bit, not too heavy, hey? Okay, let's look at the last one. Question 9. Calculate x and y, the length and the breadth of a rectangle. So very important. This over here is a rectangle. Why did they tell me it's a rectangle? Because they want you to know or to remember, that opposite sides are parallel as well, yes, but most importantly, that opposite sides are equal. Okay, and with that, you're going to create equations. And then it says hint. So they're looking for the length and the breadth of the rectangle in the diagram below. So calculate x and y, basically. Hint, let the properties of a rectangle guide you to find the unknown variables. Okay, so we know the opposite sides of a parallel, of a rectangle is equal. So x plus 10 is equal to 2x minus 20. Why is that? Because the opposite sides of a rectangle is equal. Okay, and then x plus 20 gives you 30. 2x minus x gives you 30. How easy is that? Not so hard. Okay, as the same as with those two sides. So y plus 15 is equal to 4y minus 45 degrees. So the opposite side. So I just want to be thorough and write everything down. If you don't know if you should write it down, rather write it down. Opposite sides of a rectangle is equal. So if you had to solve that, 15 degrees plus 45 degrees is equal to 4y minus y. Be careful if you do the inverse. Remember to change the sign. So 40, 50, 60 degrees is equal to 3y. So y is equal to 20 degrees. So 15 plus 45 is 60, divided by 3 gives you 20. And that is it for today. I hope it helped a lot. I hope I didn't scare some of you away, especially with these last type of questions. But it's very important that you go through these questions with geometry. The more you see, the more you do, the more you practice, the better you will do. Okay. Please, people, I am currently still a teacher as of November 2023. That's the date for today, to be exact. Today is the 20th of November. And I just love helping other students to find their groove in maths or just to practice with me. I'm a teacher at an independent school here in Pretoria, and we follow the IEB. But as we know, the IEB and the GDE or the department is very much the same. So please subscribe. Follow me if you want, send to your friends so that we can help each other through this difficult time of maths, especially after COVID, just supporting each other and helping us through and making sure that we've got all our basics covered. Okay, thank you so much for watching. Hope you have a great day. Bye.